would like to invite the next speaker on stage, Mr. Rohit Sinha, who is the Associate Director of KPMG Global Services. A little background about Rohit. Rohit leads the platform engineering, cloud, and DevOps engineering team, where he leverages his 15+ years of experience in IT and services to deliver the innovative and scalable solutions for the clients. And of course, he has experience on various domains. He is also an AWS certified solution architect and an Agile Scrum leadership accredited certification holder with immense experience in open source tools, C#, SQL Server, AI ML analytics, and of course, SRE execution. And topic for Rohit Sinha today is, of course, a very interesting topic, a topic which is retro, which is a topic of today, which will remain a topic of the future, digital transformation. So let's all invite Mr. Rohit Sinha on the stage, and over to you, Mr. Sinha. A big round of applause for him.
Hello, audible? All right, not the best time, before the lunch actually. I know everybody's hungry. And yeah, as you rightly said, I'm going to talk about transformation, but it will have a little bit of twist. Don't go by the slides. I come from I work for an audit firm, and they usually don't allow slides. So this is just boxes, okay? So pardon me for that. But what we're going to talk about today? We're going to talk about, we'll start with enterprise agility, and I'm going to bring in a lot of context from a business angle into our discussion. Obviously, we're going to talk about business and why do we do all of this transformation and how it affects the business. Then we'll talk about developer experience based on our experience in our organization. How do we manage our own products as well as our customer deliverables? Why platform engineering is important in the entire this transformation. Obviously, DevOps will come in there. And once you modernize on cloud, how this platform engineering plays a part in this. And once you have done it, how do we operate it using site reliability engineering? And when I'm talking about site reliability engineering, I'm not going to go into details of what is SRE. I'm going to talk about quantifiable way of measuring the improvement using SRE. Okay? I'll also touch on the last slide around observability. Okay? It's a topic. Everybody's talking about it. But again, with a little bit of twist, because we look at observability slightly more than just technology. Yeah? That's the first part. Now, to start with, and this is going to be a short one, so I want you guys to be interactive at the end of it, because this is not going to last forever. It's going to be a quick one, but I want questions from you guys, so please be interactive on that. Yeah? Now, when we talk about enterprise value and why do we do all of this, right? Why do enterprise want to be agile? And I'm not going to give any yarn on the agile side of things, but why do they want to do it? They want to be faster to the market, faster for the business, right? They want to be very quick to compare to their competitors in the market, right? Now, one of the ways or the tools they use is, okay, let's use the latest technology to get there, right? Can be DevOps, can be any of that, right? Now, to do that, while technology plays its part, there is a big element of culture which is overlooked. I mean, it's similar to you can take the horse to the pond, but you can't make it drink water, sort of thing. Yeah. But we'll try to decipher that and look at where when you do a cloud adoption, where does it go wrong? Where does it go wrong when you adopt the DevOps side of things? Because at the end of it, and I'll reiterate that later also, is the fact that you can have the sophisticated of your setups, but you have invested in making that sophisticated setup, but your real return on investment comes when you operate it in the sophisticated way. You just can't take a new car and give it to an old driver. I mean, obviously, he can drive it, but he'll struggle, right? And it is important that we get the best out of all the investment which we have put in, right? I'll get a little bit deeper on that. Now, oops, it's going back. Yeah. So I'm going to talk about developer experience. It's one of the key aspects of being agile. When we talk about developer experience, what do we mean by that? We're going to talk about platform engineering. Platform engineering will, in this case, and my examples are going to be very platform engineering specific, so very infrastructure as a code and infra side of things, okay? It will have two parts. Number one is the developer experience, as you can see here, and the second will be the site reliability engineering, which is a continuation of that. Yeah? I don't want to get through all of this. This is how you know how to modernize things. You define strategy, and this is where the execution part comes in, the last three, right? And we are going to talk only about the execution. We are not going to talk about the strategy and how you do things. Now, when you talk about the building foundation, it is about when you go to the cloud, the first thing which you make is a landing zone. Everybody knows that, right? You got to put the base on the cloud so that the applications can go in. Now, when you especially take care of the enterprise level landing zone, there are four things which you take care of. The identity access part of things, the network flow, the security, and the subscriptions. If that is managed, that becomes your base for your organizations to get the application on top of it. Once that base is in place, you have the application come in, the infrastructure related to that application comes in, and then comes the application itself, the code on top. That's how the flow goes. Now, it is very important that the hooking between the enterprise landing zone and the application infrastructure happens, okay? Needless to say, in the cloud world, most of these happen through infrastructure as a code. You can use any of that, cloud formations or Terraforms or whatever it is. And then you execute that modernization. So all of these are code, so all of these have their own pipelines, even infrastructure as a code. In our experience where we run products and services for customers, we have pretty robust platform engineering to do it. Now, why is platform engineering important in this? The developer experience part is very important in this because what we do is, we want the developers to only think about writing the code, which is pertaining to the business. We don't want developers to think about what they have to do in the platform. We need to provide developers a platform which they can definitely use. If I get a little bit deeper and use DevOps terminologies, if I'm a developer and I want to write some code, all I need to do is go into Git, do a pull request, and I should have all my resources available. Okay? Now, who will ensure that? There has to be a platform engineering team which ensures it. Because all this landing zone, enterprise level, and the application sitting on top are infrastructure as a code, and somebody has to manage it, make it, and make sure it is ready for the application developers to be used. That's what we call as that's what we call as developer experience. We need to provide our developers that experience of just write what is required for your application logic. You do not need to think about anything below that, okay? That's what we call as developer experience. Now, the second part is you execute your modernization. Everything is done. You have put your money. Everything is live. Everybody is happy. Then comes the real part, which is around how do you operate it. Now, most of the times, what happens is the application has been moved. Everything is fine. And they just transition it to the existing operation support, which in a sophisticated environment like this is not going to work because this is all code, including infrastructure. Your operations which have been running infrastructure, on-prem infrastructure for long are not used to this. They do not follow the classic ITIL-based, SOP-based setup in operations. This is code. The skills are different. The complexity is different. Even a change in a firewall is a code change. That's one problem, how the operations runs it. Second problem is, if it's a code change, it's a pull request. Somebody changes something in, and I'm using an example of Terraform, TFVAR file, use the sub, change it. Okay, I need this firewall to be opened. Who approves it? It goes to the CISO team, network team, fine. Can they read the Terraform code, which is in there? These are practical problems which we have seen. You can put all the money you want to do the transformation. How do you operate it, right, is the bigger problem. Just reconciling before I move to the SRE part of how we'll solve that problem, which I talked about. It is around platform engineering. Why do we need it? To provide developer experience automation and self-service, because that's how it will come down to. The third part is around the security guidelines. Now, everybody talks about security and the point of shift left. You bake it into the pipelines, you bake it into the code, what you're writing, and all of that. And then you have the accessibility, the vulnerability, the SaaS, DAST, and all of those things which are coming in. We have to standardize it. Your pull request will not go through unless you go through all of that. Okay? That is what platform engineering does. That's why it is essential that whenever the cloud journey starts, especially using DevOps, we should have a platform engineering setup being done initially to cater to all of this, which is nothing but the cloud engineers who are there to do it. And then you leave the logic to the application guys to do whatever they wish to do. And then, obviously, we need to run that. Then why do we need SRE? That flows into, now we have made all of this, how do we run it? Now, coding skills to manage IAC, that's a different thing compared to the classic operations which we talk about. The skill is different. The ITIL ways of L1, L2, L3 is different because that doesn't work that way. Okay? And then what does SRE do brilliantly is it gives you a quantifiable number of how the improvement is happening. SRE is not to take care, I mean, there's a different school of thought in this. One is the classic operations which talks about, I'll not touch it if it's not broken. Versus an SRE who says, I want to make changes at will. I don't care if it breaks. But I have to ensure that it is a resilient enough system so that it does not break. There are two different things in that. And when it comes to observability, which a lot of people still think that it is a glorified name for monitoring, okay? But it's not, it's much more than that, okay? That definition of what is required comes with experience. Now, somebody talked in the morning about a museum of tools, right? Tools can only do stuff which you want. What do you do beyond that? You have to build, and most of the bigger enterprises use these tools, but they have a layer on top which defines as to how do they use it and how is helpful for the business. I'll come back to that topic towards the end, okay? Then how do you keep velocity and pace, and then around how do you provide a continuous improvement. Now, SREs actually work on the reliability principles. In ideal world, these are the 4 things which SRE should do anytime. That's the 4 things only. And again, it's an infrastructure based, so bear with me. Change in infrastructure with code, react to an alert, review a pull request, and take long-term tasks. That's it. Ideally, that's it. There should not be, the monitoring should be or observability should be in place so that it creates an alerts which are relevant, unlike the alerts which we get today in classic ops, where you have a lot of monitoring tools giving alerts, 80% of the time, incidents, and so on and so forth. The second is, how do you define these reliability principles? I'll give an example in the next slide as to what we think could be there. Now, reliability principles will define KPIs. Operation works on KPIs, right? It's all service level agreements and things of that sort, right? You cannot apply the classic ITIL-based KPIs directly into this sort of sophisticated setup. It has to be a combination of KPIs of service management and the KPIs which are related to DevOps. Some of the principles which can be used, okay? Some of them. This is just an example. We have throughput. In our experience, we have even used ones which is one KPI which we measured, which was right first meaningful pull request. Meaningful pull request. There is a definition for that. What is a meaningful pull request? Okay. So mean time to failures. Now, mean time to recovery is one of the most famous ones. MTTR, they call it, right, in service delivery, right? It should be MTTE in case of this because it's mean time to execution. How much time does it take to execute? Because it's a code execution. It has nothing to do with a SOP-based somebody going into the system and making a change. It is about how fast the code is executing because everything is a code-based. We don't have access to the Azure AWS portal itself. You can't make changes from there. You have to go through the pipeline. Obviously, there is a break glass situation can happen, so we have that provision, but mostly it should go through that. That means all the measurements happen through this. And then based on that, you define the SLOs or the error budgets. And then, obviously, this is the most difficult one, yeah? Feature performance versus stability, availability. You have to strike that balance pretty well. If that does not happen, then it's a problem. But this is the overall framework which we have. We have around 35 odd KPIs, which is a combination for only site reliability engineering, which can be used for defining how the SRE performance and stability should start. Now, we talked about observability, right? Now, there's a definition. We talk about observability from a logging, monitoring, and traceability perspective. Observability, in our opinion, is much bigger than that. When we say, how big is it? We always end up doing that, which is technical. How about end user experience? And how about business process? Just to give an example, and this was implemented for one of the customers. A technical lag or a monitoring shows that there is a problem with, there is a lag technically. How does it affect a truck which is going out of the warehouse? What is the impact of that? That's a business impact, right? In the entire supply chain, if you have an application which is lagging behind by, say, a couple of minutes when you're uploading something, how does it impact the truck going out of warehouse for the retails? If we can get that entire chain from technology, how the user is behaving up to business, for us that is observability, okay? Now, that part is covered by most of the tools, the technical part. End user part is also covered by some of the tools, right? You can do a lot of it, you know. The business process part is also covered by some of the tools, but most of them are on ERP. Now, you have to build that for yourself. It doesn't come out of box. You have to build, if we can get in one single pane a technical problem, how it affects the end user and how it affects the business. If we can get in a single pane, that's exactly what we define as observability. Now, on this part, I don't think so we can get tools. We can get a plethora of tools which can, you know, in a combination do it. But this is one of the roadmap for observability actually should be driven by site reliability engineering because they exactly know how this is working. A lot of people still think that the SRE is only operations at a technical level, but in real definition, they should start adding value to the business at some point of time. To be honest, that's all I had. So any questions? I wanted this to be interactive, so it's like a 15-minute thing, but I wanted people to ask questions, and if it can be interactive, it will be great.